Okay, in the last question in part 3, students were asked to graph a cubic using the following graphing window. I'm going to actually do this so we can follow along because they start with one graph and then they change it. So we're supposed to graph 2x cubed plus 10x squared plus 6x minus 5 using a window that goes from -8 to 8. Scale of 2, and y is from -20 to 20, scale 5. So initially we were looking at this. That's a nice typical cubic that has 2 direction changes and 3 x-intercepts. All good so far. So now Kevin is doing this and enters one of the digits incorrectly and graphs 20x squared instead of 10x squared. Everything else is correct. And so they show us what happens, but we'll just follow along and do this. Instead of 10, that is now 20. He hits graph, and this happens. How can you tell that you're missing something if you graph a cubic and get this? Well, the primary tip is that a cubic normally does not have 2 x-intercepts. Well, it can, but it would normally, you expect it to go up and then back down and just have a point of tangency on the x-axis. So that looks suspicious. The other major giveaway is the end behavior. A cubic normally goes from either bottom left to top right, or vice versa, top left to bottom right. This one has a positive leading coefficient, so it should be starting in the bottom left quadrant and going to the top right quadrant. This one does not. And so there's got to be another x-intercept somewhere. This arc has got to turn around, come back down, and end up in quadrant 3. And we aren't seeing that, so we know we're in trouble. So there are a few answers that you could give for A. I would say the end behavior is the one that should immediately set off alarm bells. This curve you would expect to do something like that if this is really a cubic with positive coefficient. So now they say change the graphing window so that you can see everything. I tried factoring this, and I was not able to. I don't know if I'm having an off day or if this thing is genuinely unfactorable. But without the factors, there's really no way to just look at this equation and say, I must make my window go down to -12 or whatever. So I'm just going to double the x distance there, and we'll see if that helps enough. Oh, there we are. Now we've got 1, 2, 3 x-intercepts. That's a big improvement. I've got this minimum. I would like to be able to see the maximum turning point up here as well. So to make that happen, again, I'm not positive how high that is, and without calculus, there isn't any really good way to look at this and see where the max has to be. Or sorry, to look at this one and see where the max has to be. So I'm just going to double this again, and we'll see what kind of luck we have there. Nope, the peak is even higher than that. Okay. Did I change the wrong thing? Yeah, I went 4 instead of 40, so no wonder I didn't see anything. Let's try 40 and see what goes on now. Okay, still 40 was too conservative. Okay, double it again. 80. Getting closer, but this thing's a monster. Okay, instead of 80, we'll double it again. Ah, boy, okay. I admit I thought we would have gotten there by now, but whatever, we'll win eventually. There we are. Okay, so we have 1, 2, 3 x-intercepts. We have the maximum, we have the minimum. This is a pretty complete picture of what that cubic does. From its end behavior, we know this end is just going to keep dropping forever. It can't change direction again. And in the top right quadrant, it will keep rising forever.